Hi, welcome to my first tutorial about creating and distributing Python packages. This tutorial targets intermediate level Python developers, but it might be interesting also for people who consider trying this programming language, especially with Azure DevOps. Azure DevOps is a set of services to handle IT projects from Microsoft. It used to be called Visual Studio Team Services. This tutorial is the first part of a short series in which I will explain how to create Python packages, write unit tests for them, configure a project in Azure DevOps, and publish the package in Python Package Index, the public repository for Python projects. In this tutorial, I will speak about the following topics. Why packaging is a good idea, how to structure a Python project, how to test locally in development mode, how to document a Python package. So the first point is why packaging. When you build an application, you generally end up writing some code that can be reused in other applications. In such cases, it is best to encapsulate reusable functionalities in dedicated packages. This has the benefit that you avoid copy-pasting fragments of code across different projects, obtaining a better handling of code improvements. Creating custom packages in Python is quite simple. You essentially need a file setup.py containing information about your package. So let's create a package. I will start by creating a folder structure. Let's say, for example, that we want to call our project MyDemo. As I said previously, we need to add a setup.py file. Then a README and a license. Then, of course, we can add a Python package. We can call it in the same way as the main folder. So make dir MyDemo, and inside MyDemo, I will create a file, init file, so we can import in Python. Now, since I really like Visual Studio Code, I will work graphically. It should be simpler also to follow. So we open the folder in Visual Studio or whatever editor you want to use. Actually, I opened the wrong folder. I really wanted to open this one. The one containing the setup.py file. Now, I don't want to write by hand all setup because there are so many examples on the internet, and you will find one also in my GitHub repository and of course in the official Python documentation. So I will start by working setup.py file, and we can edit to configure the things we want. So a package with name MyDemo, version 0.0.1, and demo project. Now, if you want to use Markdown, as I like to do, you will need this parameter, long description content type text Markdown. So you can define the README file in Markdown, and you read it here and set it to the long description property. These classifiers you will find on the internet. There are official classifiers for Python. The URL right now doesn't matter because there is not such a repository for this project. But I will just configure a value for now. It doesn't matter. Keywords, I will put core package. Packages, we need to put the name of the packages we are defining for this Python package. So in this case, we have only MyDemo. So I will call it MyDemo. And we don't have any subfolder, so we don't need to insert the subfolders here. I will explain more later on. Install requires that you define what kind of dependencies are required by this project. So when you install it, they will be automatically downloaded. So now that we have a setup file, let's start adding something to the common project. Since I like to define custom exceptions for my projects, I will make this example. I will define custom exceptions that can be reused in any of my projects. So for example, generic object not found exception and a docstring, an exception reason when unexpected object is not found. And just to make things a bit more interesting, we'll add a new one. Invalid operation. An exception reason when an attempted operation does not make sense. Everything is ready. We can already start importing this project. To demonstrate, I will create a new Python virtual environment. So let's go here, outside of another folder, and let's say Python 3 module virtual environment and name env. It will create a virtual environment in a folder called env. Now, since I'm under Ubuntu, I want to activate the virtual environment with bean activate. Under Windows, it would be a batch script inside a env script activate batch. You can see I activated the environment because there is this prefix. And now I can install the package we just defined from the file system. So pip install. I will also use a flag called -e. It means in editable mode. It means that you can modify the source code of the installed package later on, and it will be automatically propagated to this project because it is reading the same files. So pip install tutorials, my demo, and this is sufficient because we need to reach to the folder which contains the setup.py file. And that's it. Successfully installed my demo. So now if I do Python, I can import what I defined in this package. Remember to include the name of the package. So from my demo.exceptions import object not found. And that's it. Now I have a object not found class which I can use. So raise object not found something. And you can see from the traceback that I raised an exception from this project we just created. That's great. Now, as you noticed, I added docstrings to the class I defined. So I can use help and see documentation here, the documentation I wrote previously. So an exception reason when an accepted object is not found. With Q, I will get out of the help, and that's all. Now, something else which is interesting. Since I installed the package with the -e flag in editable mode, I can add more stuff here, and it will be imported automatically by this virtual environment. Actually, it's not imported automatically, but these files are read. So let's say, for example, I add example py, and they say def, say hello, says hello, name. And I add a docstring. Says hello to given name. We can also include a docstring for the whole module. So example module, for example. Now, when I import again this module, I can import the new function I just defined. So from my demo example, import, say, hello. Now, if everything is fine, and I know already because I didn't get an import error, I can use this function. Everything works as expected. Now, what is the value of this? Of course, like in this example, defining common functions that you can reuse in other projects. To recap, we saw how to test locally your custom Python packages. It's sufficient to create a virtual environment and use the full directory path to the folder containing a setup.py file to install the package. Optionally, you can use the E flag to install in editable mode, which makes development really easy because you can edit the code of the installed package without having to reinstall the package itself. I showed how to document your code using docstrings, and I showed how to include a README file in Markdown to document your package. I will go back again on this topic later on when we publish the package in Python package index. In the next tutorial, I will speak about unit tests. I will show how to use the built-in unit test module and how to use the PyTest framework, which offers more functionalities. I will show how to debug tests in PyCharm and how to use test discovery so that we can write a script to execute the test that we can reuse in continuous integration builds in Azure DevOps. For this tutorial is everything, so thanks for watching and see you!